Hey there, welcome to dotnetFlix. Today our guest is Willem Meints, and Willem, you are going to talk about semantic kernel, right?
Yeah, that's absolutely right. I
Yeah,
think a lot of my colleagues have already heard a lot about semantic kernel by
probably.
now.
Yeah,
Um,
yeah.
yeah,
So,
uh,
but let's dive in and let's see what is semantic kernel and why would I use semantic kernel as a developer. So I'm curious to know that.
yeah. I think a lot of people have used large language models by now for coding
Hmm.
in the shape of GitHub Copilot or ChatGPT for that matter.
Hmm.
But not a whole lot of people have actually built applications that use an LLM on the inside, and that's what
Mm.
semantic kernel allows you to do. So you can use semantic kernel as a way to talk to models from OpenAI or Anthropic or even open source models that you can run on your PC. Although I have to admit that I've got a pretty big machine behind me doing all the work, so it can be pretty hard to do, but it's certainly possible with semantic kernel. And the idea here is that so using a large language model is usually done through an HTTP API,
Hmm.
and you typically use a concept of a conversation with messages. So the idea is that an LLM is actually sort of a chatbot, but you don't have to use it as a chatbot, luckily
Okay.
for us.
Hmm.
Actually, most of the applications that I built with large language models aren't chatbots at all. So they use a typical web front end where you enter information into a form, and then we do a background process that invokes a large language model. So
Okay.
semantic kernel, you can abstract away all the nastiness from all the different types of LLM. So I've got here a diagram in front of me showing off various layers of technology that are used to talk to an LLM. And the bottom part here is the LLM itself, but actually there are multiple ones, and they all have a slightly different interface. So if you
Mm.
look at an LLM from Google, it has a slightly different interface in the sense that it still uses conversations and messages, but they have other properties. So they have text instead of content, and they have
Okay.
roles that are defined slightly differently. And what Microsoft did initially is actually a slightly different diagram from this one. What they did is they started building a prototype in the CTO office that was called Semantic Kernel already back then. And they connected directly into Azure OpenAI, and they connected to Google,
Mm.
they connected to AWS, and they did some open source models, not all of them. And later on, they decided, okay, it's much better if we have a more generic abstraction layer in the shape of Microsoft Extensions AI to abstract away all the logic that's needed to talk to a large language model out of semantic kernel even.
Mm. Okay.
Um, why that is, that's a pretty special reason. If you ask me, they didn't have to do that because semantic kernel was perfectly fine providing those abstractions. But nowadays you have an option, so you can choose for directly talking to OpenAI through their own C# library or the Azure AI Foundry library,
Hmm.
or you can use Microsoft Extensions AI, which provides one layer of abstraction on top.
Hmm.
And the abstraction here is they straightened out all the property names and the enums
Mm.
and the whole logic of connecting to an LLM. And the final layer, Microsoft Semantic Kernel, that's what I want to focus on today, actually provides abstractions like tool calling, plugin model to connect multiple things together into the LLM. And they provide things like agents. And agents,
Okay.
that's the main thing that developers want to talk about because of the agent mode in GitHub Copilot.
Yeah.
Um,
And Willem,
so, so
is this all .NET, or can you also use it from different languages, different tech stacks, or?
yeah, so semantic kernel is a bit special. Microsoft tries this from time to time. You can get semantic kernel in Python, and you can get it in C
Okay.
Sharp and in Java. But
Okay.
the maturity level is slightly different. So for C Sharp and Python, it's sort of on par. They do the same
Okay.
thing. In
Hmm.
Java, they are working pretty hard to get it ready for prime time. So you're
Yeah.
missing a few things like specific models or options that are normal in .NET. Um, but it's pretty specific, the things that
Okay.
you're missing. Yeah.
And how does MCP fit into this picture?
Yeah, so just to help people along that are watching this video, MCP is a Model Context Protocol. It's a way of abstracting tools into a server protocol. So Semantic Kernel allows you to call tools. Any LLM can do that. Just to give you an idea of what it looks like. So if we zoom in on the architecture of Semantic Kernel, the central part of this whole framework is the kernel itself. It's a class. You can create an instance of this class in a console application or ask for it in a ASP.NET Core application. And into this kernel, you can connect functions. And functions is special. Basically, what you do is you tell the LLM, so you're an agent and you can use these tools to perform actions. Maybe turn on the lights or write a file or search email, things like that. So I can show you later on in C# what it looks like exactly. And the problem with functions is that you can only provide functions that are local to your application. So they have to exist in your application code, be that in Python, in Java, or C# or any other language. And if you want to reuse tools across multiple LLM-based applications, for example, in multiple agents, like in Copilot Studio or GitHub Copilot, you have to have some sort of way of abstracting the tool away from your application code. And the way that they do that is by putting an HTTP endpoint in the middle. That's basically MCP. It's an HTTP protocol. It defines a way to talk to functions, prompts also, and a resource, so you can search for things. So that's the idea behind MCP. And so in practice, if you're building an agent with Semantic Kernel, yeah, you can still use C#-based functions or Java-based functions. That certainly works. But if you're more into an enterprise environment, Semantic Kernel makes it easy to talk to MCP servers. That's the whole idea.
Right.
And so just to continue on that, functions, that's one way of extending your LLM with extra information. For example, you can let it do actions or stuff like that. And the other thing that's added to Semantic Kernel is filters. So you can, for example, filter out personal identifiable information. So right before the prompt from the user is sent to the server, you can filter out personal information or profanity, or you can verify that the person has access to a particular tool, things like that. So if you take a step back, Semantic Kernel is actually more of an enterprise level library to talk to large language model. It's certainly not the only library that's available. As I mentioned, you can talk to the LLM directly, but if you're building something in Java, you have LangChain for J. If you're building in Python, you have LangChain and a number of other less famous tools, but I guess most people will know LangChain. So that's that's what Semantic Kernel offers. But yeah, if you want to build something practical, I think most people will start building things like a chatbot. We did the same at InfoSport. We actually built two. We built Ricardo. That's our chatbot that's more general purpose. That was the first chatbot we ever built. And to be fair, Ricardo is living on this layer, on the bottom one. So it's directly talking to Azure OpenAI. It has no notion of tools. It has no notion of filters or anything of that nature. So it's actually not using Semantic Kernel at all. When I started building agents, that was like, I don't know how long ago, but at least 2 years ago, I think. And back then we didn't have Semantic Kernel, so I was using the client library to like directly. But the one that I wanted to show to you is Eva. Eva is a HR robot that we use, and just to explain what that means, because people have all sorts of associations with HR robots. No, it doesn't do anything with performance reviews. It can't. I didn't just forbid doing that. I just didn't build it that way. The idea behind Eva is that you can ask questions in regards to our career framework. So at InfoSupport, we have the career framework, and that describes different roles within our company, different levels that you can perform a particular role at. So you could be a junior developer or a media requirements engineer or a senior architect, things like that, those combinations that happen. And typically what happens with info support is that a person doesn't perform just one role, they perform multiple roles at the same time. And the challenge that our managers have is that it's pretty hard to figure out what can you expect from a person in a particular role on a certain level. So those questions happen. So what Eva is a chatbot that is actually a retrieval augmented generation system. And just to explain how that works in rough terms, is that what we do is, and I can draw this out, it's actually a lot better to do than showing this complicated picture that I have. So what happens is, if somebody asks a question to Eva, Eva will just not answer directly. Instead, Eva will say, okay, thank you for your question. I will first figure out how to obtain this information for you. And then using that information, it will try to figure out, okay, what should be the response to the user. So it can use a tool to find out things like what's expected from somebody who's a senior. That's one tool that we have. We have another tool called that actually provides information about roles. So you can, if you ask what's expected from a senior developer, it will first use the tool to find out the job level, and then it will use another tool to find out the role description that is expected. And after that's all searched by the agent, you will get an answer. Then it uses the LLM to send you a final answer. So it will send off all the information to the LLM. And the information, the response from the LLM will be streamed back to the user. So that's basically how that scenario works. And to be honest, this is already pretty complicated, but once you get into the C#, it's not that bad, actually. It's pretty doable. So just to show you some of the code that we wrote is, let me first introduce you to the startup application. So Eva is a pure HTTP-based application with Signal R to perform the streaming connection to the front end. So you see ChatGPT respond in those chunks, right? You can see the short sections of text coming back from the server. That's actually the LLM being ridiculously slow. That's mainly the problem. But we solve this by streaming you the response chunk as they happen on the model. And that sort of feels like it looks cool. That's the first thing. And the other thing is it doesn't feel as slow as it really is, because it can take up to 30 seconds to get a full reply, and that's just not doable for most people. So we use Signal R for that portion to stream out the responses. And we have a few things in place where we set up the LLM connection. So I've got a bunch of stuff here happening. I don't know if I can collapse all this crap here. No, we don't need that as well. Okay, here it is. So on line 42, we have what you can do in the startup logic, and I factored this out. So you're looking at a real application. Is I can say to ASP.NET Core, in the service collection, add kernel. So I'm creating this kernel object that we just saw in the diagram. And what I can do is I can connect it up to a language model. In my case, I'm saying add Azure OpenAI chat completion. So that's a chat completion model that can take in a prompt and reply with a response. And I'm saying I want to use a deployment on Azure OpenAI, GPT-4o. That's actually the GPT-4o model that we have. And I can set up a connection using an endpoint that I get from configuration and a set of credentials. You have basically two options to connect to Azure OpenAI. The one part is you can use an API key directly. I'm not using that. I'm using a managed identity on Azure. That's actually the safer option. And it's also a slightly easier way of setting things up, especially if you have tools like Aspire or you're doing the right thing, basically. You don't have to use Aspire, but it certainly helps in this case. And the second thing that I add to the kernel here is the Azure OpenAI text embedding generation. And for now, so you have basically two things in play when building a chatbot. The first thing is you need to generate a response to a user. And if you're looking for information, you need some way of figuring out which information is relevant. So, and the way that we do that is by using embeddings. So basically, we're saying we have a question from the user, and we convert that into a vector representing that question. And we have information that might be relevant, for example, a job description for a developer. And we do the same thing. So we turn that also into a vector, a sort of a representation, a semantic representation of that information. And if you have those two vectors, you can say, oh, are these two vectors close together spatially? And that's what we use here. So that's why you need a model to do this, to turn text into vectors. We'll get back to it and show you more details. So these lines of code, this is all it takes to set up semantic kernel in your application. From there on, you can start generating responses. And the way that I generate responses is through a specialized service, the language generation service class. And this class has one parameter in this case, a primary constructor in C#. That's the kernel object. So ASP.NET Core will provide this object to me and allow me to talk to it. And the way that I can talk to the language model is through a service called the chat completion service. So the kernel has either an embedding generation service, or a chat completion service. Those two are the most important services that the kernel provides. As I mentioned in the beginning of this video, so we're talking in the concept of a conversation to the chat model. And what you need to do is you somehow need to construct a conversation with the model. So the way that I do this is through an object called the chat history. And that's a collection of chat messages. And in my case, my chatbot has chat history. So whenever we generate a response, we save that response in the database as part of a conversation. So we store the whole history of things that people said to the chatbot. And they can only see their own stuff before anybody asks if I can see anybody's chat history. I can't. So this build chat history method produces a list of chat messages. And this is historical data, but I'm also receiving a most recent message. In this case, we're looking, by the way, at a conversation topic. The same is for generate response. So I can have this chat history. I will add the prompt that the user submitted to the chatbot. And once I have that, I can ask for a response. So I can go to chat completion service and I can say, get streaming chat message contents async. That's a mouthful. Basically what it says is I want a streaming response of type chat message. This async it's always async. There's no sync implementation of this method. Because what it returns is an async enumerable of chunks coming out of the model on Azure OpenAI in this case. So you can do a for each and then wait for each over these chunks, and you can collect them into a string builder if you want. But you can also forward them to the client if you want. In my case, I'm forwarding these chunks to the client through the Signal R hub. So I have right here in the hubs, the namespace, I've got a conversation hub. And basically, what we do is when a user sends a message to the hub, we actually send off a command to our application going into this language generation service. And that will return the async enumerable. And you can see that right here. This is the async enumerable, the response stream right here. And what we do is we call the client and we say to the client, okay, here's a chunk, here's another chunk, here's another chunk, here's another chunk. And that's how we stream back all the information from the LLM back into the client. So that's the basic chat flow that you can do with any chatbot. And in case you're wondering, of course, Eva is a pretty complicated application. Still, I'm saying, yeah, it's not that hard to talk to a chatbot, but imagine doing that to an LLM directly or having to switch models. That's a lot harder, actually. This whole streaming thing is kind of, yeah, it's not easy to set up. But once you have it, it's working great. And if you want to learn that yourself, I can highly recommend looking at my workshop. So I developed a workshop for my colleagues to teach them how to use Semantic Kernel exactly for this purpose. Build a chatbot and have it search information in a search index. So you can go through this step by step. And actually, if you're especially lazy, you can go up to the code and have the final solution as well. So you can have a look at how it works and try this yourself if you want. So yeah, we can share that in the show notes. There are a couple of things that I have to tell you to make this a full agent, actually, because right now what we have is, if I go back to this picture, I have an incoming question. It's going to the chatbot and ultimately to the kernel object, and then we're talking to the LLM. That's what I just showed, and that's it. That's not very intelligent. That's actually the first release of ChatGPT, if you will. It's actually this part that's more interesting and why you would use Semantic Kernel. And to show you, if I go back to my language service, I skipped over a few portions of code. And that's actually this first set of lines, starting on line 61, is I added to the kernel object, I added 2 plugins. I've got a career framework plugin, and I've got an attachments plugin. I'm not going to talk about the attachments at all today. That's a pretty weird thing to look at. I just want to focus on the career framework plugin because I think this is typical for any organization that tries to build an intelligent agent. They typically want to use internal information and expose that as a agent that can answer questions. But yeah, so how does this work? If we look at the career framework plugin, it's a typical C# class. There's not much special going on first sight. You see a public class career framework plugin, and it accepts a bunch of repositories to talk to the database, actually. So what I did is I stored all the job level descriptions, all the job role descriptions in a Postgres database, in this case. And the way this works is actually, what I can do is I can have get job roles function. I've got a job levels function, and I've got answer question. And what I've done, I've actually, if we look at the answer question function, I've said this is a kernel function. And by marking this method as a kernel function, I'm going to make this available to the kernel as a tool to call. So now what happens is the question to the LLM changes slightly. So going back to my diagram again, I've got this question that goes into Eva. Eva wants to call this tool, but how does Eva know to call this tool? Well, what happens is it takes the question, it attaches a piece of information to that question, tools. It basically, what it does is it applies an extra section of information to the request to the LLM, saying to the LLM, hey, I've got this prompt, this question, and oh, by the way, I've got this list of tools that you can use. And what will happen is that the LLM will then look at the prompt and start to generate a response, but that's not a regular response saying, hi, I'm Eva, I can help you. It's a response saying, hello, this is a tool call. Please, application, take this tool call and execute it for me and give me the response back So I can generate a final response. That's actually what happens. And so once we have executed the tool call, for example, answer question, we're feeding a bunch of information extra into the LLM. And based on this extra information, the LLM can answer the real question. So that's why it's called retrieval augmented generation. What we do is we have a question. We'll ask the LLM what to do. The LLM says, I want you to answer a question through a tool call. We find extra information. That's the augmentation. And then it generates a response. So that's basically what the RAG system is in this case. Why would you use a tool? Well, you can, of course, do this statically. That's what Ricardo did in the past. So Ricardo takes your question, does an explicit search, injects that into the prompt, and then generates an answer. Eva is smarter because if you ask about the weather, that's not related to the career framework at all. So it knows not to call the ask question of answer question from the career framework plugin. It knows that it has nothing to do with that, and it does nothing. Basically, it will tell you, sorry, I'm not familiar with any weather related stuff, so don't ask me. But how does it know? Well, in the information about the tools, I can provide a description and say, this function answers questions about job levels, job roles, and competencies at info support. And oh, by the way, the response is an answer to your question. And if you want to ask a question, you're supposed to provide me the question that you want to ask. And that's how so we provide extra description of things that it can call. And the LLM will figure out, okay, what tools do I need and how do I need to call them? And basically in the tool call you receive back, that's a JSON payload, and you have to parse that and call the functions yourself. And if you have things like MCP, which you can integrate with Semantic Kernel, you can have a external HTTP endpoint where you send this payload and then get an answer back and then do the whole thing with the LLM again. So yeah, that's how powerful functions are and how that works in C#. I can create functions and they can take in dependencies and they can have all sorts of logic in them. As long as I mark them with kernel function and provide additional information in the form of description attributes, I can use tools. And
those descriptions, Willem, you've written them in Dutch, in case anybody was wondering. But does that influence the performance of the LLM in any way?
Yeah, it does. And so the LLM is pretty language agnostic in the sense that if you ask a question in English to Eva, she will still answer the question with the right information, but it's slightly less useful. There's a lesser match between your question and the available tools because the tools are in Dutch and your question is in English. And right. I decided on using Dutch in this case because all the users of my application are Dutch. So yeah, you have to think about how is my application used and then provide the right description for that. And if you're using ready-made tools like the GitHub MCP server, don't worry about it too much. The performance is still good enough, and models are getting better and better and better basically every month. So I guess this will play less of a role in the future.
Right. And Willem, are there any restrictions on the size of the data that is returned by such a tool? I can imagine that obviously you have the memory of where your application is running, but are there any restrictions in the APIs or something like that?
Yeah, there are restrictions in the sense that you have to return data that's JSON serializable, otherwise it won't work at all. The size of the payload is limited to what the context window of the model is. So I should explain this a little bit more. In all reality, LLMs don't use conversations at all, despite what I just told you. They use sequences in and sequences out, and they have what's called a context window. And the context window is the size of the input plus the size of the output. And they usually specify this as we can take in 1 million input tokens, but only 8,000 output tokens, which means that if you want to generate a response to a user, you can have 1 million tokens worth of information on the input side, and it will produce an output of maximum 8,000 tokens. And what's a token? A token is basically a short word or part of a longer word. So these four letters could be a token, and the last 3 letters could be a second token. It's basically how that works. In terms of real things, these days you can put a whole book as input to your LLM, and it will still provide a reasonable answer. There's one limitation that we should cover, and that's also covered in my book that I wrote about this topic, and that's actually if we look at this one extra picture, the problem with the context window is that the model is slightly stupid. So if you have a piece of text at the start of the conversation, that's pretty well remembered by the LLM. So if you would ask it, where do we start with the conversation, it will answer pretty well. Anything that's at the end of the conversation is also remembered pretty well. But stuff in the middle, that's sort of, I don't know, I keep forgetting. That's what the model thinks. And it's like in a real conversation with somebody, people usually know why they came up to a conversation and how the conversation ended, but the middle portion is not. I mean, that happens. At least I've met a lot of people, and I'm the same.
That's why we try to keep these videos short, Willem.
Yeah. So that's the thing here with LLMs, and Semantic Kernel is a pretty useful tool, I think, especially because of those tools. And people should know that if the LLM gets a tool call back, it gives you a tool call back, and you call the tool, it can do a second tool call right after that. So if it decides that I've got an answer to the question for the job role, but not to the job level, it will do a second tool call and try to find that information as well. That's called reasoning, and most modern models are pretty good at that stuff. So if you're building something with Semantic Kernel and you worry about, is it going to call all my tools? Yeah, it will if it needs to, if you give it a more extensive prompt. So again, if people want to try this out, I highly recommend looking at the workshop. The fun thing about a workshop is at the end, you will have a working chatbot complete with the front end, so people can use it. There's no authentication. That's the one downside to this. So don't put it in production directly. I recommend you spending some time fixing things up, but otherwise it should work pretty well.
And you shamelessly plugged a book of your book. Can you tell us more about that?
Yeah, so while building agents for info support and other LLM-based applications, I got a comment from our CTO and my own manager. You should talk about this a little bit more. And I decided, I can approach everybody personally. But instead, I wrote a book about it, building effective LLM-based applications with Semantic Kernel. It takes you through the process. What is an LLM? How do you set up a Semantic Kernel application? Up until complete workflows and pretty complex stuff. It's all there in there.
We'll put a link in the show notes. So if people want to order this book, you can just follow the link in the description of this video.
Yeah.
And also to the workshop. We will also put a link to the workshop in there. So awesome.
Cool. And one the one last thing I discussed this with Sander earlier. If you're into very complex prompts and doing some crazy stuff with LLMs, then I can highly recommend this repository as well. This is actually something that I made this weekend. If you don't want to follow my workshop and basically let AI build your agent, then you should definitely follow this guide and do some pretty crazy stuff. This can implement full features from start to finish using Cloud Code or GitHub Copilot Visual Studio Code. You can do the same thing for Semantic Kernel.
Yeah, so this is really like a layered approach to using multiple agents to do each part of your development process, right?
Yeah.
So creator requirements, validate the design, come up with a plan, and then finally execute or write the code.
Yeah, all the principles that we just talked about are in GitHub Copilot. And so if you understand somewhat of what I just explained in the video, you will have an idea of why Claude Code and GitHub Copilot are able to do this exact thing, building features from start to finish.
Nice.
Yeah.
That's very cool.
Yeah, and the one thing you forgot, by the way, is review your own code, and then it also does a great job of reviewing someone else's code. It's pretty amazing stuff.
Yeah, it's very, very cool. Yeah.
Nice.
I do still recommend manually reviewing anything that comes out of it, but
Definitely.
Yeah, that's a good tip.
Cool.
I was working with Copilot. I think it was GPT 4.1 as the model. And I did generate some code with Postgres and T-Framework Core, and I needed to have a concurrency token. And with SQL, you use row version for that. But it completely missed that with Postgres, you have like this, what's it called? Xmin column, which is automatically set by Postgres. You can use that as a token. But then you need to define your property as an unsigned integer. You need to add timestamp. It completely missed that. So it came up with let's say, more complex solution that was totally unnecessary. So yeah, you still need to know what you're doing to get those strange things out of your code and do a really good review. But it saves you a lot of work, man. Really.
Yeah, I think if you would save 2 hours building a feature, then you can spend at least half an hour reviewing the stuff that it generated. That's
now you actually have time to do the reviews.
Yeah, but it's fun. I think not enough developers are actually experimenting with this stuff. So what I at least hope that people take away from this video is that Semantic Kernel allows you to build more complex things that go well beyond custom Copilots in Copilot Studio and the custom GPTs. And once you understand this layer of using an LLM, I think you have a much better understanding of what you can do with other agents like Copilot or the coding agent, for example, on GitHub.
Yeah.
So thank you very much, Willem. I'm sure we'll talk again very soon because all of this stuff is evolving crazily fast. If you like this video, please like, subscribe, buy the book, and we'll see you next time. Bye-bye.
Bye.
Bye.